because it always starts speaking to me. We're also sponsored by JetBrains, and one lucky person will win a 12-month license to a JetBrains product. And we're also sponsored by stickers, but I can't give you the stickers because they won't go through the webcam. Tech Nottingham, as I mentioned earlier, they're one of the biggest technical communities around in the Midlands and certainly in Nottingham. And yeah, they're organising some fantastic events together with them and women in tech as well. So do go and join their Slack community there. Well worth doing. I mentioned earlier JetBrains. If you tweet on the hashtag NotsIoT and your name is Alan Buxey, then there's a good chance that you'll win a JetBrains license. So if you don't know, JetBrains make developer tools for developers, things like IntelliJ and WebStorm, PHP Storm, ReSharper, and stuff like that. So one of you lucky folks will win a 12-month license to one of those products. Tonight we've got Jorge Ramirez and Adrian Stevens. I see Adrian's joined there a few minutes ago, talking to us about how to build connected things with the Meadow and C#. There's Adrian. Awesome. Thanks for joining. And then and normally at this point I'd be saying next month, but there is no next month because it's August and holiday season, and I think everyone deserves one of those. So with that, and also IoT Live's taking a short break, but if you've not seen IoT Live, then Cliff Aegis and myself, we run a little show on Tuesday evenings and then quite often on Thursday lunchtimes. Tuesday evenings at 9 p.m. BST. Just Tuesday evenings is really just a talk around IoT and what interesting things Cliff and I have found in the week, and often we'll have a guest as well on there. So yeah, that's worth checking out at that address there. That's part of the Azure-ish channel. There's a whole heap of other shows on that particular channel as well, so keep your eyes on that. And if you're interested in upskilling your Microsoft IoT knowledge, then myself and some other authors have created a learning path series of tutorial videos for that. And if you're interested, I've got some 30-day all-access passes for Pluralsight, should you want it, which is good. What if you're not on the Twitters? Then if you're on LinkedIn, then put it on there and I'll do a special check for you. I'll just include you in the list of people, if that helps you there, Chris. Hard other than that. I mean, we do it so that people tweet about Nots IoT, really. That's kind of the reason. Quid pro quo. And then myself and Liam Gulliver, Jonathan Rolfe, Misha Bell, and Louise Paling, we run the Agile Engineering podcast, and it's worth checking that out on all good providers. And with that, I'll finish waffling and pass you over to Adrian and Jorge. I'll make Adrian as well a co-host, just in case you need to share. There you go. So at this point, if you just put yourselves on mute, if you want to ask any questions, stick them in the chat, and if there's an opportune moment, I will ask them, obviously. But other than that, we'll just ask a bunch of questions at the end, and that should be it. So yeah, enjoy. Thank you very much.
Fantastic, thank you. And Pete, my day job, I work at Microsoft actually in the on education. I'm part of Microsoft Learn. And so I'm a big fan of certifications, and I'm going to go watch your IoT prep content on Pluralsight because I'm working on that certification next. So that's very exciting. Excellent.
Thank you. Yeah, cool.
Today we're going to talk about IoT, and so I'm getting the sense that this group's probably pretty up to speed on IoT. It sounds like you guys talk about it pretty regularly. How many here have tried Meadow? I see a couple hands up, but it's both from Clifford. A couple heads are shaking. So we'll do the intro. So sorry if you know the intro already, but usually throw in a couple things. It'll be interesting, even if you've used the platform. We're talking a little about the IoT landscape in general. Again, I think people are pretty well versed here, but it's kind of fun to think about. And then Jorge's got some really cool demos, and this is quite exciting in that we just released a new version of Meadow. So with every new version, there's new capabilities. So it's always fun to show off some latest and greatest and a little bit of performance improvements on the way. Jorge, anything you want to add before we jump in?
Yeah, welcome everybody. And thanks, Pete, for inviting us over for this meetup. we're very excited to show you some things that you can do with C# running on microcontrollers. So yeah, I hope you enjoyed our presentation.
Fantastic. And Jorge, it sounds like you're a tiny bit muffled. If you have a option to adjust your mic.
Oh, okay. Let me see.
And also, Mark Stevens joined. So Mark has also been grinding away at the Meadow stack. So hey, Mark. Good to see you.
Afternoon, evening.
Oh, hi.
So we're pretty casual in our presentations. So Mark, obviously, you're welcome to jump in anytime you like. And that's true for us as well. You can save questions to the end, but feel free to just jump in and ask as we go. And with that, I'm going to pull up some slides where we'll talk a little bit, and then we'll get to the fun stuff that is the demos. Share screen. Let's go with that one, and let's make this full screen. Hey, look at that. Excellent. Mark, had I known, would have added your name to the slides. And so again, I think this group knows us pretty well, but IoT, it's kind of a big deal. Oh wait, I'm not hitting the share button. I was just zoomed. There we go. That's what I wanted to do. Perfect. So yeah, IoT, it's really a big deal. And I think this group gets it, but I really love to reflect on this and that this really is going to be a major cultural change. Really, in a lot of ways, it already is. And that we've seen IoT really become a major part of our lives. We start thinking about things like simple devices like the Nest or connected appliances, all of the connected technology in cars and such. It's the new epoch. The world is changing with IoT, and it's really kind of fun to think, hey, we get to be part of that. I love this little story of that. With that, we've seen some major technological changes, right? I recently watched Hidden Figures, which a fantastic movie, and that idea that they were doing all those NASA calculations by hand. It's crazy town. There was a time when we didn't have computers, these kind of calculations. Then we've just seen these evolutionary jumps from a mainframe to in every home to in every pocket. And now it's almost like into everything. Big market. If you happen to see the numbers, they're impressive, and they're impressive not only with the dollar amount, but also that we think of mobile as a really present, really obvious technological change. Where hey, we've all got smartphones with crazy compute power in our pockets. It turns out the IoT market is significantly larger than that very public and obvious mobile space. I love this number: 75 billion connected things by 2025. That's more connected things than people's. Pretty fantastic. So yeah, our lives are already changing. We talked about this a little bit. Again, the idea, desk on your computer, it's a great quote, and now it's really a computer in everything. Lots of fun. I'm gonna zip through some of the raw. Pardon me as I flip through slides. I think this, this is a fun thing to talk about. It's just, it's with that, it's a major market, it's a major opportunity, and what's interesting is, thinking about things like mobile versus IoT. Again, like mobile, I love the term hero product, where we had the iPhone, or we've had like flagship phones. They're very public facing, and we see it's very obvious. IoT is a little funny because it's sort of under the radar, it's behind the scenes. And so we're not always aware of how big this market is. And a lot of times, people are doing this as enthusiasts, and it feels like a hobby project. I don't know if the rest of you are like me, where you've got little buckets of parts everywhere, and it sort of feels like you're adults playing Lego, which is a great thing. But we're actually building skills and that are going to be not only very valuable career choices, but probably critical to the future of, well, not to overstate it, but like our society. And it's because these little guys, right, our little microcontrollers. And the idea that these things are getting down to dollars and pennies and that can power everything is pretty shocking. And what I love about this is on our little Meadow boards, we're talking about in a lot more detail. We're like, yeah, we love our microcontrollers. We love them so much. We thought, hey, you know what? Why make a board with one when you can make a board with two? And I say that jokingly, but it's actually quite cool. And that these things, the commodity prices are getting so low, that's reasonable. We can specialize this hardware and get really great performance without making these cost prohibitive. I'm going to pause here. I've been talking a lot. Jorge or Mark, anything you want to add on?
Yeah. So I think I think, yeah, the IoT revolution, it's a silent one for sure. And I think every company are trying to come up with their own ecosystem, their own solutions, but there isn't like no hero effect, like no outstanding product that's like taking it over and that everybody will follow. So I think there's a big market, and it's all collaboratively happening for each company trying to come up with their own thing. But I think eventually we try to standardize everything, so we get all the IoT developers not too messed up into trying to make their own solutions, you know. So yeah.
Love it. Absolutely. Yeah, I think the standardization is a big one. We'll talk about that a little bit when we do some coding as well.
Yeah.
I think you got the story from the stats, but yeah, IoT. It's an interesting thought though, right? This is going to be really the dominant form of computing on the planet. To me, it's even sort of weird to think that, hey, mobile is probably currently the dominant form, where there's so much compute power in people's pockets. Whereas, I think like I'm probably a company here where you see I have multiple laptops. I still think about compute as the things that sits on my desk. I'm working on a desktop, but yeah, this is really shifting. Other markets, people don't have laptops. They don't have desktops. They have phones. And IoT is going to continue that trend where things are just going to have that compute and that intelligence. There'll be more compute power in all of our appliances and our things than there will be on our dedicated compute devices, which is almost mind-boggling.
Yeah.
We'll talk a tiny bit about this, but I think this is a group that gets us pretty well, but it's kind of a fun little talk about what is a microcontroller, right? So a microcontroller really it's a little compute device. It has the ability to do calculations, all the wonderful things that we know our computers can do. And one of the key characteristics of a microcontroller is that it's that compute system on a single chip. So the memory is embedded, the controller is embedded, and it's a low cost single package. Again, we saw the little picture of a chip. Well, that's our microcontroller. It has everything it needs on that chip. It's not like a traditional compute platform. Think about building our old desktop computers. We've got motherboards and RAM and separate bits and pieces. It's all embedded on a single chip, and it's built to control hardware. This is quite fun, actually. And what's interesting is this really all started a long time ago, before I was born, with the first microcontroller in 1971 from Intel. And so really microcontrollers have been around for a long time. And what's interesting, I think, here is that, as much as we're saying, hey, it's a revolution, the world's changing, we've actually been at this for a long time. And that's kind of true of a lot of things that change the world. They don't happen overnight. It's a long, slow build. But some things are changing our world to make this to really ignite our ability to embed these things. And that's a lot about cost and, of course, connectivity. Not a CPU and not an app processor, right? And really we're focusing on this here. Actually, I'm going to pause. I'll ask Jorge. So Jorge, what do we mean by not an app processor?
Right, yeah, so microcontrollers are very lightweight and energy efficient piece of technology, pieces of it's like a small processor, and its sole purpose is to run whatever single tasks that is deployed on this system. So compared to like an app processor or a regular CPU in our computers, they're based on doing a lot of multitasking. I have Zoom, Visual Studio, a bunch of stuff open, and the processor just try to go bit and switch tasks really fast, repeatedly through all these tasks, so we can try to keep everything running at the same time. With microcontrollers, that's not the case exactly. It's all about just going through that single purpose of the app or the application that you deploy to it. So I think that's kind of what it is, right, Adrian?
Yeah, I like that. And I think there's some fundamental differences, and we use this talk a lot for the kind of the introduction to. And again, I feel like this audience probably gets it, but it's good to be reminded that when we think about microcontroller versus a general purpose processor, the kind of computer chip that processes in your desktop or laptop, these devices are generally meant to be single purpose. They're not meant to multitask across applications. They're not running a complex OS that allows you to launch simultaneous processes and systems. And of course, you can run multiple processes, but they're not meant to multitask. They don't have a multiple user environment, single focused, purpose-built hardware. And yeah, talking about that, I think we'll probably jump into the Meadow stuff. I think this group's probably pretty up to speed on the ecosystem. Lots of them, talked a lot about that. I'll talk about this a little bit in the context of Meadow. So in that idea of, hey, single purpose, not an app processor, doesn't multitask. And of course, these devices don't run full OSs, right? So in Meadow is a great example of this. We're not running Linux under the hood. And we do see that sometimes in IoT devices where they're microcontroller-like, but they're really little tiny computer systems. And they do have full multitasking environment under the hood that's just been sort of cut down to work on a lower power processor. On a microcontroller, we'll say sometimes we'll say there's no operating system. There's no operating system like we typically think of Windows or Linux or Mac OS. But of course, there is an OS, but it's a very thin layer OS that gives us access to the hardware. And in this case, like a real-time OS. And what's critical here is it's not responsible for providing a GUI environment. It's not responsible for providing, user interface. It's responsible for giving us quick and very lightly abstracted access to the hardware to allow us to connect to the physical world. And I do love this little bit here, measured in kilobytes, not megabytes, right? Super lightweight, super fast, super minimal. And so there's a bit of work left on our part to make sure that these devices can do the things we want to do. With that, though, obviously we get the low energy and low cost. We talked a little about that already. Obviously, with these kind of devices, though, they're much better at doing things like embedding them in remote systems, running them off batteries, running them off solar. And we often get these kind of conversations of, hey, well, how about Meadow versus Raspberry Pi? And they're both really cool devices, in my opinion. Obviously, I'm partial to devices like Meadow. It's near and dear to me, but I love Raspberry Pi. It's fantastic. But a Raspberry Pi really it's a small computer. It's not a microcontroller. Although they're getting pretty efficient, you're not going to get the same level of power efficiency as you are on a true microcontroller. And yeah, absolutely, Alan. Like, yeah, 1/1000th. Obviously, based on the hardware and the peripherals, that value changes. But the power consumption is significantly lower because you're building purpose-built hardware. So you don't have the overhead of managing multiple applications, of adding in bits and pieces of hardware, things that you do not need. Mark, since you're here, anything you want to add to this?
Nothing at the moment, thank you.
Thank you, sir. I'd have Mark here because he can make sure that I'm not saying anything foolish.
Cliff's actually asked in the chat there, what is the power draw of the F7? Something like a Pico is quite high for a microcontroller, but I don't know what the F7 would be.
Yeah. So, Mark, I will ask you, have we measured that yet?
Yeah. So, from startup, which is probably the most heaviest power usage, we peak at around about 300 odd milliamps. We average out at about 180 milliamps during the startup process. The thing is that is a full startup of 2 operating systems on 2 chips with mono running on top of all of that. The long-term aim is to start enabling some power features now. We've got things we're getting closer to final release. So you'll be able to do things like drop the STM32 and the ESP32 both into a low power state and have them wake up and do processing on a periodic basis. So you should see your power draw drop dramatically once the board's actually up and running. And you go through this, let's say a weather station where you might say take weather readings every 15 minutes, upload them to the cloud, and then you just put this system to sleep. So you should see those the power draw drop dramatically at that point.
Cool.
Good. I couldn't have answered that. I will say this, though, from the layman perspective on this, even in its current state, and we've got some fun little device research for testing. I lost a button there. It's a little game system, and we're able to run the software standard. I'm going to put the name of the battery now. The 1860 650. And this will run for couple hours, no problem off this battery. So even in its current less optimized state of Meadow, we're still actually getting nice low power draw and are being able to run off battery. Buy cheap, yeah, little things get cheap. We're $10 is aspirational today, but I think it's well within target. But we're likely to get these, embedded versions of Meadow down nice and cheap. And this is again really cool. And that ability to get things down into the dollars and pennies means that we can put them in a lot of things and build a lot of those purpose-built applications, things like wearables, appliance enablement, and such. Yeah, so I alluded a little bit, but I like this, the why now, right? We talked about this before that, hey, we do microcontrollers for a long time, but why now? Why is it a big deal? Well, first things first is, not too surprising, but these do evolve. Microcontrollers are getting smaller, better, faster, more efficient. Obviously, the microcontrollers we're using today, like the ESP32 or the STM32, these are significantly more powerful, more efficient, and you get a lot more performance per dollar, per penny that you did on that 4004. And again, really just about the, I think it's head. Yeah, and also the supporting ecosystem here of commodity hardware that we can use to build these solutions. So it's not just about the microcontrollers, but it's about all the wonderful bits and pieces, boxes of parts that we have today. Commodity cheap. They're readily available. They're very, very low cost. They're becoming very efficient. We have access to a global ecosystem. Even during a pandemic, we can still get great stuff most of the time. And we can build very complex things very, very easily. This wasn't possible 40, 50 years ago, or at least it was a lot more challenging. And then, of course, the internet makes this all very exciting as well, and that we have very, very easy data connects and such. So we can use these devices in remote locations, gather a lot of information, and build very complex systems. Let's focus a tiny bit on Meadow. I apologize, I'm jumping around a little bit on slides. I want to get to the demos because the stuff Jorge is going to show you is a lot cooler than me talking about hardware. But this is a fun little thought, just thinking in the spirit of evolution and in that idea that we are getting more efficient. Basically Pentium level performance on these tiny little things. So that's pretty crazy. I still remember buying my first Pentium and paying a lot of money for it. Now we're talking dollars, pennies. And not, it can't play, it can't yet. I love that question, play Doom. But honestly though, these processors are capable. I don't think there's any reason the STM32, and Mark, call me out if I'm wrong, but I'm pretty certain we could get comparable Doom performance. When you're talking Pentium, Doom ran on a 386. Full authorization, this should be possible. Or Wolfenstein only. Love that. But there is graphic acceleration on the STM32 F7 that we're using. It does have some 2D acceleration. It's not currently unlocked on the Meadow stack, but it's coming. Will be a little bit RAM showing your age. I still remember Wolfenstein. That's good stuff. Yeah, but yeah, it's cool. You don't expect to be playing, Unreal on this, but yeah, we can play some. I think this will be very capable of graphics, of relatively graphically intensive systems using high-speed interrupts like SPI with your displays and such. Mark. Jorge, anything you want to add here?
Yeah, well, in this slide, I think, something that is missing is we have a slight coprocessor here, that is the ESP32. So mentioning in the slide is we also have Wi-Fi connectivity here and Bluetooth, which is something very big. Like there's no Internet of Things without connectivity. So if you get one of these boards, you already have access to go into the internet and start getting information or posting data of whatever you're sensing, as well as Bluetooth as well. We have Bluetooth connectivity inside the board. So you can also do your solutions of, building a Bluetooth app with your phone and start doing things to control it remotely. There's also that possibility. So it gives you a lot of liberty with those two features alone of having connectivity on the board. Something that I also really like is that we have is what is called the Watchdogs feature, and I always remember from videos about NASA that's like, you have to have a plan B if things go wrong. And I think Watchdogs is the go-to in this case of when something goes haywire. This feature will automatically kickstart your application to reboot it. So say if you have several of these around in the wilderness to monitor different sensors or something, and if it fails, you don't have to go with your computer on each point on any tree and start deploying your app again to make sure it runs or hit a reset button. Just this plan B feature will just automatically try to reset the board and try to start the application for you. So that's also pretty neat. Yeah.
Love it.
Just so you're aware, Brian is watching in the YouTube feed.
Oh, nice. Okay.
Hey, excellent. Fantastic. All right, so we've talked about the story. We've talked a little about getting us here, and we've talked about the opportunity. We can do a lot of really cool things with hardware. And then what I want to talk about just a tiny bit is just kind of the current state of IoT. And feel free to jump in and add to this conversation. But I think this is generally still a fair statement. We've gotten to the point where the hardware is relatively easy. We have standard ways of connecting things. We have standard bus protocols. We have standard voltages. We're generally settling on 3.3 volts, so we can buy peripherals and plug them in and know we're not going to fry stuff. But the challenge is not getting the hardware. The challenge is controlling the hardware. And the software in IoT today is very hard. And that's, of course, the problem that we're hoping to solve with Meadow. How many of you here are .NET developers? All right, let's put some hands. My hand up as well. Don't make it too easy. I will say that even Meadow in its beta state, it's getting easier to build things. And I just like, I could just start coding little apps instead of doing my day job. Yeah, and that's really one of the problems we're trying to solve here is be able to rapidly prototype and build solutions. Where a lot of us are app devs, and we're used to building on, really great environments like Visual Studio and Visual Code. We've got really nice dev tools where we've got repeatable patterns, reusable code and libraries. Again, C# devs, we're using things like NuGet. We're pulling that stuff in, and we can put together apps really, really quickly. Previous life, I worked at Xamarin, actually with Brian. And I used to build training curriculum, and we'd build sample apps. And it was a blast because you could pull stuff in, you could grab packages, you could build mobile applications in hours. Sometimes less if you're feeling really quick. I used to live code things during classes. And that's really powerful, and it really starts unlocking your creativity. And that's the kind of thing we want to do with IoT. We want to get past the how do I make it work and what's possible, and move into the what's possible, really creative building. So yeah, full .NET apps on a microcontroller. This is actually really a big deal. For those of you that use .NET, you're probably aware of the .NET runtime. It does a lot of fun things. It gives a little bit of security. It gives us managed memory. And that's not a trivial thing to run on powerful hardware, let alone a microcontroller. And this is really the secret sauce of Meadow, is getting a version of that runtime working on embedded hardware. And not only getting it working, but getting it working with modern .NET, meaning that we use modern .NET practices, modern coding practices, and giving us access to all those wonderful libraries and things that we get via NuGet. Jorge, anything to add on here?
Yeah, so I think that there's been approaches to try to bring .NET into the micro embeddable world. So one of the attempts was the NetDuino to run .NET there. So they came up with the .NET micro framework, which is a very smaller subset of the whole .NET ecosystem, which was fantastic at the time, but also sometimes it started to age, and when going to full .NET, going to .NET micro framework, sometimes you want to go in through certain APIs, and darn, they're not there. And so, it's a bit of a challenge of try to think into much simpler terms and try to adapt to to the limits bound to that framework. There's also, I think there's also Nano framework, which is also like it's also a subset of .NET, because the whole point is trying to get everything as lightweight as possible so it's able to run into these devices. But getting a full .NET to run on Meadow is, you know, the biggest achievement we've done yet, and there is no compromises running on those APIs. I mean, the same .NET you'll be running on Xamarin, like getting to things, using things like HTTP client, or using, you know, string operations or things like that. You'll feel just like at home when you're working on Meadow, which is something really cool.
Fantastic. And with that, what do you think about jumping to some demos?
Sure. Yeah, let's do it.
And to call Chris has joined too. So Chris, feel free to jump in and contribute at any time. Don't be shy.
All right. Given that the audience, it's relatively new to Meadow, I am going to show you a very basic project, and I'm feeling risky here. I'm going to do a little live coding for you guys to get you familiar of how you would work with Meadow. So let me share my screen. Share this one. Move this aside. And oops, wrong window. Let me bring my window to the view here. And here is a Meadow F7. So notice we have here some cables running around to certain ports or pins. And I'm going to start slowly putting peripherals there and start adding some code. But let's start to the first thing. And let's just do a simple Blinky project. That's how we call it. Let me close this project here. And sure, I have this, that we have a repo. It's called Meadow Project Samples. And there's where we do all different projects, and we document them so whoever has a board and wants to get familiar with Meadow, they can start following them up. I'll go into more detail about that, but for now, let's just do a simple application. First thing you'll have to do for the Visual Studio side, you need to download and install the Meadow DevTools for Visual Studio. That way you'll get things like just the project templates and all the deployment process to actually, you know, upload the application into your board. So I have click file new project, and as you can see, we have already 2 types of projects. And it's not only that we don't necessarily work with C# alone. We also have access to, you know, for all the Visual Basic folks out there, and F# as well. We support these 3 languages for now. I'm the most familiar with C#, so let's try that. Let's do Blink, and let's create a project. So the purpose for Meadow is we want to empower the developer to make hardware as easy or simple as software. So as Adrian mentioned, when we're working with hardware, it could feel like a grown-up, like an adult Lego set, and we want to recreate that same experience when using software. So for that, we created this thing called Meadow Foundation, and Meadow Foundation is it's a platform or a library that contains over 100 different drivers, and each driver we've carefully curated, and we are providing a set of very abstracted APIs. So the user can just grab whatever piece of hardware they want, they plug it into the Meadow board, and you new up an object, and you already have access to all their functionality, or at least 90% of the time. 90% of it, it was still in beta, so there are some things that, you know, they're rough about around the edges. But yeah, we're every iteration we strive onto getting them. We try to get them better and improve them. So when you create a Meadow application from scratch, the first thing you will find is an RGB PWM LED object. So right now you can see on the board here, we have this little LED. It's actually an RGB LED. But putting a pulse width modulation signal on it enables us to go into more than 7 different kinds of hues of colors, because we are actually manipulating all the signals in all 3 channels, and they give us, you know, millions of colors and intensities. So the main paradigm of these projects is always we have an initialize method, which is in charge, or is a code region that is charged to just specify Meadow what kinds of sensors or peripherals or buttons it has connected to. And then once the initialization process is complete, then we can just start playing with the objects. So in the case that we have the onboard LED, we're specifying what type of device it is. In this case, is the Meadow F7. And we have a set of predefined pins that we have access to. So when you do device.pins, we have a bunch of, you know, 6 analog pins. We have SPI, I2C pins, and we have 15 digital pins, and which 12 of them are PWM capable. And so having access to also the onboard LED and the green and blue pins, it already gives us access to control this little LED here. So once the onboard LED object is done, all we need to do is we can start using the APIs. As I mentioned, we can do things like start pulse, and we'll see the LED pulsing. We have start blink as well. So, and we can specify duration times of when, how long we want it to turn off and on, and things like that. We can also manipulate the brightness if you don't want it fully on or fully off, things like that. Let me run this application. So on the extension, we have a Meadow Device Explorer. So we need to specify on which COM port your Meadow is connected to. So once you select that, we do deploy, and it'll start building the application, and it'll start deploying all the necessary DLLs so the application runs. So when you get a Meadow fresh out of the box, you'll notice that the first deployment, it might take a little bit longer than the next iterations, basically because, you know, your file system is completely empty, and the first deployment will actually go through all the necessary files for your application to run. That is MS Core Lib, system.net, some of the heavy ones that I've mentioned. But the extension it's smart enough that whenever you run your application again, it'll look into your files and see which ones have changed, and it'll just deploy that. So you don't have to be stuck on every deployment re-uploading all the files over and over. So in your development cycle, you will just modify an existing library or your Meadow app, and that will be just a file that upload, which is really small. So it speeds up the process of building your application. Adrian, anything you want to add to this?
No, this is fantastic. It's a nice sort of tie in back to that story of, you know, we have a lightweight OS on the system. And so, you know, normally if you have Windows, you're going to get a lot of these baseless libraries installed through various things. And they're just there present in your system. We are deploying those. We're setting up our environment on the board. And exactly Jorge said, this will happen. This will be a little slower the first time we deploy. So to copy those base class libraries onto the device. And what you'll find is whenever there's a major update, you're probably gonna have to go the cycle because we'll likely have revised the DCLs. But then it's very clever on new deploys and make sure it checks the CRCs. And you guys see it going through here looks like Jorge is actually updating a board that had a previous version. So some of the CRCs aren't matching. So it's deploying new versions of those bins.
Exactly. So you can see on the packages, we have a reference to Meadow Foundation. So we have a core library that brings already gives us access to the most basic peripherals, because obviously we don't want to jam all 100 peripherals into a single library that will take up all the space on your board. So there are slightly more complex drivers that they have to be their own NuGet package. But things like, LEDs, push buttons, rotary encoders, all those sorts of things are going to be included right out of the box. So notice that, I didn't have to add an LED NuGet package. Everything is embedded into the Meadow Foundation core project. So that's the main reason why when you create a project, it already comes at least with this capability. While this is deploying, which is still taking a little bit.
We actually have a good question here. If you don't mind, I'll jump in.
Yeah, sure.
So the question is, do we need extra non-VS Code tooling along with the VS Code extension? So for Visual Studio Code for deploying, I'll be honest, I haven't tested Visual Studio Code much yet. That's on my to-do list for next week. Mark or Jorge, have you been using it, the VS Code?
I tried it in the previous release on 5.0. I haven't tested it on 5.1. I think this is a public contribution for enabling us to work on Meadow on VS Code. But I haven't tested it on 5.1, unfortunately.
Right. But I think for setup, it's just VS Code plus the extension, correct?
Yes, for sure. Yeah.
I say that with high, but not absolute confidence. And then Clifford asked an excellent question. Are you not linking out the libs? Not yet. And there's some challenges around that in terms of the linking versus the validation. So how we actually check the CRCs on the linker. That will be coming. We've been experimenting with that. The challenge is that the libs get relinked on every compile, and then the CRCs don't match. So we have to do a little bit of trickery in terms of crawling the properties and such to get a unique fingerprint. Long story short, it's coming. It's coming.
How long does it take for a typical build and deploy to device?
Yeah, I would say I'm going to say about 30 seconds usually.
Yeah,
maybe even less, depending on if you're once you've got your DLLs deployed. So that's now completed here. If you're working on the same app, same hardware config, the next deploy now will only have to deploy the actual application, the exe that goes across, and that's very quick. Yeah. And then there's just a little bit of overhead we reset the Meadow device, does a little bit of validation, then does the full startup cycle. Starts the OS, starts Mono, starts the application.
Exactly. And I can show that firsthand. Now that we finally deployed our first application, this is kind of like the time that it takes to do a first fresh deployment cycle. So you can see the LED is slowly pulsing between all these different colors. You can get to see it more in detail once you do a file name project, and this is what it'll come out of the box. So I am going to move forward, and I am going to add now a simple LED that I have here. So I'm going to put it right here. There we go. And now a practice that I have the habit of doing now is whenever I use my onboard LED to indicate me when the initialization has started and ended. So what I can do is I do onboard LED, set color, and now I do color red. And this will give me indication once it hits the initialization method, the LED turns red, and once that method is done, everything's good to go, I turn it to green. I'm gonna get rid of these methods right now. And okay. And now I'm gonna do is a PWM LED. Let's do red LED. And now I can do red LED, new. And same deal, we pass in the device, we specify on which pin is connected, which in this case, it's pin 7. Seeing something, oh yeah. Oh, the 4 voltage, of course. So I think it's typical 4 voltage. We have a numerals here to specify the optimal voltage to pass in for different LED colors. So in this case, I choose red. And now I can do, say, a method called start. Let's call it here, start. And now I can do red LED start blank. So let's do the very simple task of just making the LED blink. And now we click deploy. And now in theory, it should take much less time to deploy it.
Yeah, this is finishing quick. So you can see right there, skipping file, so it's the hash match.
That's it. See, that's less than 10 seconds, really, really fast deployment. So that will speed up your cycle of development. So there you go. You got your LED blinking. Just, for newbies, it's kind of like, yay, we did it. For tech savvy, is like, okay, let's move on to something a little bit more complicated. Now let's do, say, I think everybody works with buttons, even on, your standard desktop or mobile applications. So, I think I'm missing out. Yeah, I'm not putting this here, right? There we go. Okay, so I got a button now. So let's do now, let's add here a push button. Button. And button, fortunately, also is included in the Meadow Foundation core library. So we can just include the button. And now we do, for the button, you pass in new push button device. Where is between terminals? Oh, yes, thank you. Yeah. Okay, good thing I'm reading the messages. Okay, there we go. Thank you, Tacky. And let's pass in the device, pins, and this one is connected to D02. Perfect. And now for here, you'll find your typical event handlers, right? So say if we have a clicked event. There we go. And now instead of a start button, let's just do, you can just do a start blink here. I think we have 20 minutes left. So bear with me. I'm gonna have one last exercise here, and then I can go and dive into the harder stuff. But there'll be just a glimpse of more complex things that you can do. Okay, so let's run this application now. I also put on a compilation of blog posts, and it'll go into more detail on these basic components that are included on the Meadow Hackett. In the case of the push button, there are 4 different ways that you can wire it. It also talks a little bit more in detail about interrupts and pull up, pull down resistors and all those things. So you can try to dive in a little bit more in the electronics and get a feel of what is actually happening. But for now, just try to let's just follow my lead here on if I'm building a project and how simple and so far it has been to make these applications. So the button is newed up. It's connected to digital output 2. If I click the button, it should start blinking right away. And there we go. Perfect. So I'm going to do one last exercise, and then we'll move on to the hard stuff. But I want to show you is how to connect a servo controller, so a servo motor. So I'm going to put it here. Does camera see it? Okay, camera see it fine. Perfect. And now the servos, we have a library for that because there are all different kinds of servos out there. So we didn't want it to cram it also in the Meadow Foundation core. So if we go to the library, we do Meadow Foundation, Servo core, and there we have it. Cool. Yeah, I'll show in the can I demo? I can demo our game platform Fuego if people want to see it. Okay, yeah, Adrian, for sure. Yeah. Let's do this last one, and then I can pass it on to you. So we do a servo. Let's add the namespace here. Perfect. And now we do servo. We go to initialize method, and then again, we're just saying to our Meadow board here what things are connected. So now it has a push button, LED, and now we'll have a servo. Pass in a device. Device.pins. Pins. And this one is connected to D10, okay? And I need to do a named servo configs. Every servo has its own set of properties to do the full range. There's what is called the ticks and the angles. Some of them are continuous. Some of them can do a 180 degrees. So we condense them all into named servo configurations. So we have a bunch that are here existing. So you don't have to deal with that. You can create your own servo configuration and pass that as well if you want to customize, or you have a servo that is not in the known servo configurations. Oh, Brian is there. Hi, Brian. Yeah, exactly. You can also create your own custom servo configs. I did that a while. Sometimes, especially with this servo, some of them are knockoffs. So even the values, sometimes they might be a little off. So I play with those values to try to get the full range sometimes. Okay, so we got the servo here, and let's see if I push a button. Let's do servo, rotate 2. Let's do async void, and I can do let's see, task. Oh, I haven't added it to the namespace, have I? Task. Here we go. Let's do for 1 second, and then let's do 90 and then 0. Oh, right. So yeah, something I'm forgetting. We also are adding, we add Meadow units. So we now can do things like we pass in, we can create an angle, and we can specify which angles, which units we're working on. So in this case, we do degrees like this. And then let's pass in and then turn it to 0 here. And also, I want to initialize my servo to start at a 0 degree position. Okay, so let's just deploy this. Yeah, units is a huge on this platform. We are especially for things like, you know, for temperature sensors and distance sensors. It's really nice to. Oh, okay, there we go. It initialized and it's in its 0 position. So now if we press on the button. It does 90 degrees and then it comes back. That's it. Cool. This is all I wanted to show you at the simple side of Meadow things. You notice how everything, get a feel of it about how everything is very plug and play, very, very easy, very fun to do these kinds of things and not fiddling like, oh, it's a servo, so you have to go into the data sheet and implement your own logic to do that. It's Meadow Foundation just handles it with that and does a really good job. So let me show you another project here, and then I can take it up to Adrian if he wants to show our in-house retro game project, Juego.
Yeah, it's muted.
Oh, we got a question?
The camera's off, isn't it?
Oh, okay. So, oops, where is my window? Okay, there it is. Okay, so this is I call it my Wi-Fi weather desk clock. And this one, I have it next to my 3D printer and I always leave it there. I wanted to get my indoor and outdoor temperature at all times. And where is my, wait a second, where is my solution? Projects. Oh, I closed it, didn't I? Yes, I did. Okay. So notice here we have, what do we have connected here? We have a character display is a 20 column by 4 rows of characters. And we have over here an LM35 analog temperature sensor. And we have connected all these different, these are data lines, and it's basically using GPIO to write text. It's also, it's the same deal. We have a character display NuGet package. You just add that, and then you specify to Meadow which pins is connected to what on your character display. And if you wire it properly, then you should be able to write text really easily. So this is the Wi-Fi weather clock. It's the last project in our public repo for project samples, and this is a little bit more. It has a little bit more stuff for sure. So we have same deal, the initialize method. We have an analog temperature sensor. I do start updating. It's something that we've added recently in the recent features, and it's about monitoring analog states or analog ports in the background of our application. So what I'm doing is on every 5 minutes, on time span 5 minutes, I want in the background to the sensor, to the analog temperature sensor, to read the temperature of the room. So that way I'm constantly having an updated value of the room temperature that I'm in. I did also a little bit of abstraction here. I didn't want to have all my character display logic, so I created a class called display view, and display view is just an abstraction or encapsulating the logic behind the character display. Oops, I zoomed out of it. But the character display, it has an initialize method as well. I specify all the pins that it has, how many rows, how many columns, and then I have methods for update the display, which outputs this all this strings here, which is the date, the time, and the in and outdoor temperature, and the overcast. The weather description. Now you would ask, like, how do you get the weather the weather information? So I have a couple of methods here. First thing we'll have is the datetime service, because this is another question. How do you get your datetime? And even though Meadow has an onboard real-time clock module, we always need to set the date onto the RTC module, and then it will keep up and following up that time. But what I do is to get the actual time, I use this public service API. It's called World Time API. It's just a basic GET request. You pass in, the different parameters. You do America, and then you put here Vancouver, and then it'll find the local time here. And let me move this aside here for a second. And then here is the get datetime method. And if you can see, it's just doing what is that you will be doing on a normal desktop application. You do HTTP client, and then you do normal get async method, and it will return you that data. And we are just using normal JSON, same JSON you'll be using as Xamarin apps and Newtonsoft JSON, and you just deserialize your object here, and you just return the value of your datetime. Same thing with the weather app. I use Open Weather Map, and I pass in the city and my API key for that. For this service, you need an actual API key, and same deal. You have a HTTP client. You call a certain API using that, doing a GET request or a POST request, whatever is needed. You deserialize the readings, and I get back all the data, and I massage it, and I eventually just show it onto my little character display. Are there any questions? Okay, I think Brian and Taki are answering them. Adrian, anything you like to show off? Is he here?
Oh yeah, no, I'm here. I was just over on my Mac getting it set up. I can turn my camera on if you like.
Okay.
You want to do another demo, or should we just stick to Q&A for the last 5 minutes?
Sure, we can do that as well. Yeah, are there any questions so far? Brian and Chris are very chatty over here.
Fantastic.
Yeah, I think
That's good. Yeah.
pretty much sorted it in the chat. It's awesome.
That's good. Then let me just continue, and I'd like to close with another. It's one of my most favorite projects, and it's this little guy here. Let me remove this from my camera here, and then this one's on set. And this is a radio player, actually. So this one's already has the application deployed. So this is, sorry about that, the camera. Go, production lights, action, there you go, okay. Cool, so this is the radio player, and I really like this project. Adrian gave me the FM module here, and this is also super cool. You can see this one has two, kind of like the headphone jacks, but one of them is actually for the antenna, which is connected right now, just this guy over here. And check how everything that we're doing is, we have a couple push buttons, as I've shown before. We have an I2C display. It is 128 by 32, if I'm not mistaken. Let's go to initialize method here. Okay, yes, here we go. We got our RGB LED. We turn to red. We create an I2C bus. And notice how this display and this, the FM radio module, they're both connected by this green and blue cable. It's because both of them use the I2C protocol bus. So we actually use the same bus, and we can control multiple peripherals. So they both have, obviously different addresses. So we can just connect different lines of peripherals that have I2C, and then we can just control them all like they're separate entities. So we got this display is the SSD 1306, and as I guessed, is 128 by 32 pixel resolution, and for the radio module, this is it to initialize it, which is something mind-boggling. It's a TA5767. You just pass in the I2C bus, which you use to communicate, and that's it. That's all you need to do to just initialize the radio. No additional pins, not anything. You pass in the ID, and now there's some APIs here. You have select frequency. I pass in a list of predefined local radio stations. You can tweak them to your local radio station frequencies. And the buttons are actually used to go back and forth these stations. And then obviously you would use the other headphone jack to connect to either a speaker or a headphone, and then you can start here. And it's here. The quality is really nicely. And after doing changing the stations, we go back to display text, and I show the information about what frequency you're selecting. So yeah, that's all the projects that I wanted to show for this session. Yeah, anything else, Adrian, you'd like to mention?
No, this is all kinds of fantastic. And what I love to point out here is when we're looking at the code, we're really just looking at C#. So like in this case here, look at display text. Yes, there's a specific API. It's a very lightweight graphics API, but there's really nothing in your display text method is specific to hardware. This is just C#. This is just writing code. And it's such a powerful abstraction. We set up our hardware data configuration, and then we just do what we do. We write C# code, in this case in Visual Studio 2019, using those tools. It's still very, very cool to me that we can build hardware like we build software.
Yeah, and this is like the prototyping stage of a project. You have your breadboard with your LED, with your Meadow sitting next to each other, and then you can start doing, getting more fancy. That's up to Brian, because he's been learning how to churn custom PCBs. So we got this guy right here. This is our QA board. And this one, what it has is, you have your Meadow connected here, and we have all these different kinds of sensors here. In this case, we have, oh, there you go. We have, this is an SPI and a capable display. This is an I2C, and we have an array of sensors here. The purpose of this board is for QA purposes. So we test things like all the analog ports to make sure they're working, make sure we didn't break anything about the I2C SPI. If we see graphics here, I think it's a good indication that the buses are working correctly. We do Wi-Fi tests here as well, Bluetooth, all that sort of things. Because the project has been, the releases have gone bigger and bigger. We have enabled more features over time. So QA has been a little bit more intensive, a little bit more time consuming. We have a lot of things to test, and we try to ensure every release is as robust as the previous one. So yeah, so this would be the next stage, is you come up with your own custom PCB boards. And then finally, when you go into production, you can actually, well, that's in the future, but we're planning on making SMT module Meadows. They'll just sit on top of your solution, which will make them much smaller form factor. So you don't have to have this big, which is rather small, if you ask me, compared to Arduinos or Raspberry Pis. But you can also, it's great for making bigger projects and a larger scale. It also drives the prices down a bit. Cool. All right. So I think that was it for today's session.
Fantastic. Love it.
Cool.
Adrian, did you say you were going to show us, was it Huego or something like that? Or?
I can show. Do we have time? Do you want to go long? I'm happy to show that product as well.
Hey, we've got all day and all night, but you've got a day job, the pair of you. So.
Oh, this is good. This is my lunch break. This is perfect. So I'm going to show you another project. It's a hobby project that's slowly morphing to something that we think has got some legs on it. But it really embraces that spirit of, I'm a longtime dev and I like to code, and this is where it's fun. We're getting to a place where we can just build stuff. And I'm going to start with the prototype here. Because as well. So you've been watching Jorge show the Meadow board. So we have a nice little Meadow board here and on our prototyping board. And this is those are here. So this is an SSD 1309. It's API compatible with 1306. It's a nice, big, bright OLED single color display. And although it probably looks bright here, it's even brighter in person. I'm a big fan of these. And a little button array and a piezo speaker. And so what this is it's a little game player. And so it's got a number of games on it. I'm going to show my favorite one here, Frogger. So I can navigate upside down. Where the heck is it? All right, frog it. Sorry. All right, perfect. Okay. And it's glowed, and you can see it's actually running some animations. So it's actually loading some really basic single color bitmap graphics and such. But what's powerful here is actually layering up a number of technologies here. So we've got obviously the button interactions, the interrupts, the screen display. In this case, it's SPI, and then also leveraging our menu system called text display menu. And I'll get this board on my face so you can see me talk. But what's really fun about this project, I'm going to show you some code in a moment, is we've had a good time going beyond just the proof of concept stage into some early circuit board prototyping. Brian's like all here, he's the mastermind that's able to design the hardware, but actually gone through a couple of revisions where we're building out physical hardware. And then of course, a next step after that would be to take these and build a 3D enclosure. And these do work. I'm actually gonna take a chance here and plug the battery and see if it's charged. I'll make sure on the cable otherwise. I'll fire them in a second, but these are actually fully functional PCBs, little Meadow board in the back here, and this is like a feather-wing format, so standard format. Ooh, it's booting. Let's see. There we go. There's the game on a little SSD 1306 display. Same code running. And I love this as just an example of how we can go beyond, kind of like think of the Lego phase, or we're grabbing the hardware, we're building stuff. It's a ton of fun, but we can start to actually make real things. And we're in a world now where we're not talking 5 or 6 figures of engineering costs. We're thinking really low cost PCB printing, off the shelf commodity parts. And then with that, let me show you a little bit of the code as well. And sorry, I just need to be enabled. I switched computers, so I got to be re-added as a host, if that's possible, Pete.
Oh,
sorry about that. I switched to my Mac. And I won't spend too long on the code, but I wanted to show you, it's a nice example of a more complex project. It is work in progress. If you spot any code smells, feel free to point them out, but I'll claim ignorance on. There's Brian calling me out, apologizing. Love it. And yeah, are you able to give me screen share permission?
Oh, I can't.
That's a very good point. Hold on, I think you left and came back, didn't you? So
yeah. Sorry, I changed machine. Sorry about that. There it is.
Don't apologize. There you go. Apologies.
My apologies. So let's get that up here.
You're apologizing again.
Get that away. And oh yeah, I got the diehard quotes. Let's go to code. This computer's a bit messy. Okay, so again, I won't go through it in detail. You saw a lot of how we wire up apps, but some fun stuff here. So this is a nice example of, hey, we're actually trying to look like a bit more of a full-blown C# project. We've got code in folders. We're not just a 1 and 2 file app anymore. In this case here, we've got games folders. And this is the logic. And what's fun about this, I'm going to open up the Frogget games. It's pretty basic. And I'll admit, I think this is a little bit of I ported from some open source and a little bit of cleanup in C#. But what you go through here is you're gonna see this is just regular old C#, some doubles, some int, some enums, a little bit of data embedded in the class here for the logic. This is controlling where the logs are and the cars and such. And again, pretty standard. Write yourself a simple C# game. And then what's fun here is this is conforming to an iGame interface. I can show that to you as well. In this case here, it's really just supposing an interface for standard inputs. So we can control the game and then do an update. But again, we're starting to see some architecture. It's an app. A lot of fun here. And then of course, we've got other games in here. We've got Pong and Snake and a few others here. But the same thing, they all conform to that interface. And what this lets us do, of course, is now swap in these games. And where this becomes powerful is back to our graphics library. And we have a standard graphics library we're calling micrographics, which is very nice for our microcontrollers. It's a lightweight, very simple integer-based 2D graphics engine, which is really perfect for, well, our little simple displays like this. But what it lets us do is not just support this one display, this SSD 1309, but it allows us to support things like a full color. Sorry, it's not powered on. This is actually a full color. This is an ST7789 TFT display. This is 16, actually up to 18-bit display, or even fun things like our e-paper displays. But it's a common graphics API. So if we go back to our game interface, you notice a couple things here. Well, when we call initialize, we actually pass in a reference to the graphics library. Notice that the interface doesn't care about the hardware. It's still just regular old C#. And you'll see that pattern the whole way through. Now, of course, there is some rendering logic in each game, but that rendering logic is just coded against the graphics library, not the specifics of the hardware. And this lets us do some fun things. Now, this is where the code's a little bit messy, but you get the idea. Been a lot of, this is a bit of hack and slash on my test projects. But in my initialize method, where we set up the hardware, I've actually got different profiles set up. In this case here, this is set up for my prototype board, the one you just saw. But we've got other configurations. We've got config 1C, and those are actually different displays. I can switch between different hardware profiles for this code just by initializing, by calling a different initializer. And what is beautiful about this is the rest of the code is unchanged. This is the only place where I need to modify the code to swap out hardware. And this is where the Meadow Foundation APIs become really, really powerful. We've got really nice abstractions, lets you do things, back to where we were joking earlier about even like the atmospheric sensors, temperature and humidity. Well, there's a whole number of temperature and humidity sensors, but by coding against the interfaces, you're able to swap out hardware in your projects without substantially rewriting your code. You want to bring in a modern temperature sensor, you've got a newer one or higher accuracy, or you just need to swap out parts from the build. Well, if we code against the interfaces, the abstractions, that's all very possible without rewriting from scratch for your entire hardware platform. I'm trying to think of something else really clever I want to show you in here. I'm just going to show you a tiny bit about our menu here too, and this is a little bit fun. So I mentioned text display menu. I'm just going to reset this and show you the menu on the app as it boots up here. Actually,
by the way, one thing about those sensors is that it's not just consistent across like all temp sensors are iTemp sensor. Like that's really fantastic. You can swap out like an analog temp sensor works the same way as a BME 280 or a 680 or an SI 7021, whatever. You can swap in and out with whatever you need. But also sensors work the same across the entire breadth of Meadow Foundation. So every sensor, nearly everyone today implements read for one-off reads or start updating and stop updating. So you can either do one-off reads or you can just start a thread of having it go off, update, sleep, and that's something that we're making consistent across the entire Meadow Foundation. So the idea here is that this is really like you learn how to use one thing and you know how to use the whole thing.
Thank you. Yes. Brian obviously is one of the masterminds designing that as well. So I was going to show you. So a little bit. So yeah, this is actually kind of fun for the abstraction quickly on start game. Actually, I'll show you the menu code first. Sorry, as I zip around. Let me show you the initialized menu codes. This is text display menu, and there's a couple fun things here where I can show you both. There we go. Knit menu. Bear with me as I've forgotten my code of how it's all wired up again. Perfect menu enable. So I'm looking for, we're actually doing the initialization of the specific menu items, and it's not coming to an end. Here we go. There we go. Sorry about that. So text display menu. So this is a standard a menu interface, and it's relatively lightweight. Does nice basic simple text menus, acquired from hardware.
But again, it's all abstracted and it runs on top of that micrographics library. So again, same idea. We can use this menu system across a wide variety of displays. As long as displays conform to our graphics interface, they can all leverage our graphics library, which then can all leverage our text display menu. So again, we code to a standard. We don't worry about which exact piece of hardware we're using. And then this is a little bit of fun here too, where we actually have a couple of ways of instantiating this menu. It can't be done completely in code. And this project's been fun because it's been both a way for us to test out our APIs as well as make some really great example code. And so here we're instantiating everything right in C#. It's all done in line. And again, this is just regular old object-oriented coding, send your menu items, throw into a collection and go. But of course, it can also be loaded from a JSON resource as well. And we can even get fancy for things like this, where we can pull things down from the internet. JSON obviously very common, and so we can do dynamic menus based off something from an API as well. And you can see the codes commented here. They're going back and forth between the local definition and the JSON, which is embedded in my file. And then it's a tiny little insight into text display menu itself. So you can see we're defining our menu items. It's actually a really powerful little API, but in this case, I'm using it in a fairly simple way where it's a relatively flat menu. So I have a number of entries, and then we define a command. In this case, it is just a string, but we can pick up that command. So when a menu item is selected, and we wire up the hardware to be the selector on menu, we click a button, that's gonna raise an event, and I can check this command and then make decisions based off that. So in this case here, I've got a start game method, which will be triggered from the event. I can find when it's called in because you're passing in a string command. In this case here, yes, we are using magic strings. A little bit of abstraction would be great for code cleanup here, but you get the idea. We pick up the command, and then I can instantiate the game object. What's really nice here is, okay, well, we implemented the iGame interface for each game type. And then again, standard hardware. So that's going to allow us to switch through and create this menu environment. We can select things and then do full rendering on our hardware. This is all running on an STM32F7. Pretty cool. Any questions? And does this satisfy your itch for a slightly more complex project?
Perfect.
I have a question, Adrian. Where do people go to look for all these projects?
I would ask you that question, but the short answer is Hackster and GitHub. But I think Jorge is really the master here, so I'm gonna let you answer that if that's okay.
Yeah, sure. I was just asking you if you have your screen open, if you can just go to the Hackster website and show off all the projects that we have in store. I think we have about 50 projects. 50 combined with Netuino. But it's a nice collection of.
Here, I'll pass it back to you, Jorge. You can grab it if you like.
Okay, sure. Let me share my screen again. It's a nice collection of introductory projects, so people can start getting familiar with their applications. I have this I think over 2 years now, and I've made several projects so far. Some of them you can do them with a Meadow Hack kit. Some of them you'll need extra hardware, like this built-in Wi-Fi connected clock. There's also using that same Juego project that Adrian showed off for Tetris. That same code base is running on this project here. It shows you how to make your own Tetris game, and it's just using a joystick. And I think this is Max 7219. It's for matrix of 8x8 LEDs put in side by side, and you can play Tetris on it, which is something, it's very fun, engaging to build. I've made also some projects of connectivity for using Xamarin Forms as a companion app to do certain things. I do graphics, a little bit more about weather applications. There's another implementation of the desk weather app, but just swapping and using a different display using the graphics library that Adrian mentioned. So yeah, I think this is a good starting point of whenever you get a hack kit and you can start playing and making all these projects. Another thing I wanted to show before closing is if you go to developer.wilderness.labs, you can see all the different peripherals that Meadow Foundation offers right now. So we go peripherals tables here. You can see all the core peripherals that we're including right out of the box when you do a file new create project. You'll have access to all these things. There's analog joystick, temperature, LED, push button, piezo speakers, switches, rotary encoders. And then we will dive into libraries and frameworks such as graphics library or text display menu, which is what Adrian was showing. And then we got a breadth of more peripherals. We got audio, we got several displays, e-paper displays as well, which are super, super nice. More displays. We got feather wings. Again, Meadow is built by the feather form factor, so are completely compatible with these guys. ICs, we have LED strips. This is also a fun one to work with. We have motors, RTCs. Well, you got the idea, all the different different sensors that we're offering. And then each one are basically, they're properly documented. I would say 98% of them. If we go say to rotary encoder, for example, you will find something like this. It will give you a little blurb of what the sensor is, a link to its GitHub source code of the driver, and a little explanation or a little code sample of usage, along with a Fritzing diagram to show you how you wire it. So yeah, we have a very strong documentation site we try to cover as many and document everything for other users to play with. So yeah, that's what I wanted to show. Any questions?
Yeah, so Clifford asked a really great question. So it's like, be sure if it's in core, then if it's in the foundation library, otherwise it's in a separate package. Yeah, that's a really great way of looking at it. Exactly it. So we've got, Meadow, we call it Meadow Core. That'll be included every Meadow project you make, and then it has some low-level base peripherals. And then Meadow Foundation Core has a lot of the common peripherals. So it has things like our analog temperature sensor, and a lot of those basic. And then for anything that's more specific, like a display driver, servo, specific I2C or SPI drivers, those are most likely shipped in a separate NuGet package.
Exactly, yeah.
And again, just pulling up like, Visual Studio 2019, just browse NuGet packages, Meadow space, the thing you want. The keywords are in there, the descriptions are in there. They should be relatively easy to find. And let us know if they're not, and we'll make an update.
Like in the case for this obstacle project radar thing, we're using several things. We're using a servo. We're using a distance sensor that is mounted on top of the servo. We're using a display. So if you when you add all the NuGet packages, you'll see that not only Meadow Foundation it's included. We're now including the TFT SPI, which is a display, the distance sensor, and the servo core, all different separate NuGet packages.
And the dependencies have been done intelligently. So for the displays, for example, they'll automatically pull in the graphics library. So you notice that we don't have a specific include for that, because the TFT SPI NuGet package has that dependency, and that's pulled in automatically. So you're not fighting and searching for dependency packages.
Right.
And then there's a question, are there any commercial projects based on Meadow board? Nothing yet that I'm aware of, but I think we're getting close.
There's actually a ton in development right now. Some getting ready to ship.
Chris asks there about VS Code as well. How easy is it to use VS Code? I think we kind of touched on that briefly earlier. There's a community development for that, isn't there?
Right. So we did talk about a little bit about that. I worked on the previous release on VS Code. To be honest, I haven't tested the after this release. The 5.1 is a big release because we shift all our projects and drivers to .NET Standard 2.1 rather than being on a .NET Framework 4.7.2. We did the proper adjustments for VS, the extensions for VS for Windows and Mac. I'm not sure what's it standing for Visual Studio Code. For the previous release, I made this little blog post of showing you how you would build your Meadow, how to develop Meadow projects using Visual Studio Code. And basically, you just need to add an extension. There was a public contribution, again, by a very good enterprise developer. And yeah, you just do run.net templates, and it gives you an output of what is available to create these projects. So you have C#, F#, Visual Studio Basic, Visual Basic, which is basically the same project templates that we have on the VS extension as I showed. And you do .NET New Meadow, and it'll create a project for you. And then, yeah, so when you're building and you're debugging, we don't support debugging at the moment. We're planning on working on that for the next release. But right now, it'll just, whenever you run the application on VS for VS Code, it might look like it's debugging, but it's actually not properly wired. So you might need to, when you click the play button, you need to stop it to continue editing and redeploying again. But yeah, so overall, it's very easy. But I have to test the newest version. Debugging for full VS, not yet. We were very close for this release that we did. We decided to just get it right and solidify it for the next release. Yeah, no, I haven't. I couldn't demo debugging right now. As of now, console write line has been our friend for debugging at the moment.
I had a quick question. Can you do any amount of AI at the edge there? Would it handle TensorFlow or something like that, or the equivalent down there on the Meadow?
So it can handle it from a hardware perspective. It doesn't handle it in the sense we don't have anything built in yet. I mean, you can run like your own models if they're C# code, but like what we want to do is get TensorFlow Lite and OnX running. And specifically, one of the things that we want to do there is actually run that on the ESP32 coprocessor, because that would allow the main STM to continue to handle inputs and IO. And then we could use one of the dedicated, there's 2 cores on the coprocessor. So we'd like to shove that, put your model over there, run it there, and then get your results back over to the STM. So that's the plan there. I don't have a timeline for when we're going to have that up and running, but it's definitely a priority of ours.
Fantastic. I like the sound of that. Thank you.
Yeah, it'll be fun. It'll be nice to be able to offload that to the coprocessor too. That's a really cool architecture, because then you can, you don't have to interrupt your IO stuff.
Yeah, hardcore. That's great.
And I've just come off mute because he's been typing it, and it's easier for me to explain it. You've said there's lots of questions that myself and others have asked, and it's on the to-do list. It's obviously you've got a big to-do list, and it's great that all these things are coming to Meadow. But do you have a kind of a plan of what all of these to-do items are in? Is there have you mapped out a path that you're working to, and is that sort of available to us mere mortals? Is that hidden somewhere?
We've got an internal roadmap to V10, but beyond that, it's really about prioritization around commercialization products. So if you have a commercial product that needs X, Y, or Z, let us know, and we will prioritize features to that. But we don't have a public roadmap, and part of that is that it's really hard to forecast dates and timelines around these features, because there's so many unknowns. Like we move one rock out of the way and there's another rock behind it. We're like, huh, and then you move that one, and then it's sort of like Sisyphusian. So yeah, we don't have we try not to give like dates, because we don't want to give something that we can't meet.
I'm not looking for dates. I'm looking more for these are the things that we want to have in to meet an RC or V1. And these are the things that won't be in V1 but are on in the back of our mind. We think about it and they will come at a later date. It's not the dates that interest me. It's where things sit within the team's kind of thought process. Because I've got a client that would like to use the Wilderness Labs. They've got a few of the boards sitting on their benches in their offices, but until it comes out of beta, they will not use it in production, because to them beta means it'll break. That's literally what they say. Even though I said, well, this stuff is working. You're using Arduinos. Come on. But I just want to get away from Arduino C, really. But it is literally, if I could go to them and say, look, here's a roadmap that the team are committed to for the RC or V1, this will be in. So let's develop now and be ready for when that drops. And I don't need a date for when that drops. It will be at some point, whenever. But it then means I can push them towards it. But it needs to be public, really, for me to say, look,
yeah,
let's kind of build something towards this release that's coming along, because it will be in before V1.
Yeah, we should. I think you make excellent points. I have one here. It's sitting on my desktop in a markdown file, but we should definitely get it into public. We should publish it. We should sit down and figure out like what should go into. Yes, we should publish it.
You take the dates off, because if you miss a date, you upset everyone. So just don't put dates in it.
No, you're right. We should put in. I mean, then there's a ton of stuff, and it would be good for folks to know what we're up to and what we're working on. Like, do people know that we're working on DMA? Do people know that we're working on the SD card thing, or all the other stuff? So yeah. Totally. In fact, I just put it on my to-do list, so we'll get it up.
Do list to make a to-do list. I like it. And for anyone that's ordering them, about 50% of the time when I've ordered them, it's real hit and miss. I've ended up with a customs charge getting them into the UK. I don't know why, but it's just been a customs charge, which has been a few pounds, and then a few pounds to UPS or whoever it was that shipped them. Again, that was why I mentioned, Brian, about there maybe being a UK importer. Like Primaroni is one that you'll know and love in the UK. But yeah,
we've got some Primaroni peripherals here that we have supported. So yeah, no, we should. We'll definitely expand our distribution. In the future. I think today, we don't do enough. Numbers in terms of like the dev kits and hack kits to be able to take the distributor hit, distributor cut. But I think in the future we definitely will, for sure.
Okay, cool.
And agreed. It'll just make it a lot easier to get them in country.
Yeah. It also means people see them, because they'll go to the store and say, "Oh, what's that new thing? Let's have one of those."
Yeah, that's right.
Cool. Thank you. That's my questions answered. Thank you very much. Awesome talk.
I agree. Really cool.
Yeah, I was just testing the Visual Studio Code extension. I definitely need some update. We'll investigate that and try to get it very soon. There are some things that we needed to fix. So we'll try to do a quick update, a lighter one to fix these things.
Cool. Yeah, we can tail it this weekend.
Yeah, for sure. All right, thanks for having us, Pete. It was a good session. Everybody, thank you all for showing up. I really appreciate it, all your attention, and I hope the takeaway of all this presentation, it gives you more interest in our platform or what we're building. I think it's actually pretty big, and we're very active. Feel free to follow us on our public Slack channel if you want to join the community. We have We have a Twitter there as well. I don't have the handles right now. That's a little impromptu, but it's. But yeah, at the very least, you can you can find us on twitter.com of Wilderness Labs, and there we normally post. We're very active there, and we post big announcements like blog posts or Hackster projects or releases, things like that.
Discord as well. I think you've got a Discord channel as well, haven't you?
Discord. We don't have a Discord server as of now. We only have Slack channel. The Slack. Channel for now. Yeah,
we did have Discord early on. You're right, and then we decided that Slack was better.
Yeah, that's fair enough.
But also, I posted a link for our newsletter. That's a great way to keep in touch. We send out a newsletter about not very often, so you don't have to worry about us spamming your inbox. But it's like once a month-ish. We send out a newsletter, and that's a great way to know and get pushed information on when we're shipping and whatnot.
I had another question written down. I've just spotted. Can you run something like Blazor web server on there? Blazor server on there and serve a little Blazor site?
Not yet, but hopefully soon. Actually, we do have a thing called Maple Server, which is an ultra lightweight RESTful web server that you can use to make very lightweight RESTful API endpoints. And we'd like to get Kestrel up and running. And I think actually we're not so far away from that. So once we have Kestrel up and running, then you'll have full ASP.NET, and that will be, fantastic. I don't know about Blazor because I don't know the ins and outs of Blazor, but definitely Kestrel is something that is on our roadmap for sure. And supposedly, the noise is that it can run because it's now .NET Core 3 compatible, but I haven't actually seen Kestrel run on Mono, and I've done some digging and haven't seen that anywhere, but I did send an email to David Fowler, and we're supposed to sync up and figure out what we need to do to get that going. If nothing else, when we move to .NET 6 this summer and fall, then that should be, the plan is to officially support .NET 6 in November when it launches, but we'll have we'll have the beta of it up and running, but that should actually solve it totally, but we'll see.
Awesome. I suppose if that's all it's going to do is just serve a Blazor thing and do a little bit of bits and bobs, then it's fine. Adrian's pointed out in the chat there, it's a bit heavy. You're right, there's definitely far slimmer implementations of servers, but just thinking to keep these .NET devs doing .NET, it's what .NET devs are using these days, isn't it?
Oh yeah, I'm a big Blazor fan, absolutely. Interesting about how we wire that up. I want to try it now, but one step at a time.
Excellent. Well, thank you very much. A round of applause for everybody speaking tonight. And I ended up with a whole heap of Wilderness Labs folks coming along. It's fantastic. So yeah, really appreciate that.
Trickled into the party, didn't we?
Yeah, it's good. Yeah, that's the best sort of party crashing that you can have. That I like it. So there is no Not So 2 next month because it's August and everyone's going to be away anyway. So it'll be September by the time we get something back there. I've not booked a speaker for September yet, so I'll put a tweet out at some point. We do have the JetBrains draw to do, and I see there was 2 tweets there. One from Alan Buxey. I should just send you one every month, JetBrains voucher there, Alan, and also one from Sander Vandervelde there. But I'm feeling quite generous, so I'm actually going to give 3 away. And I know Chris, was it Chris Claxton there at the start? You asked if you could have one. So being as you asked very nicely, I'm going to give you one as well. Mainly because, of course, the fact we've not got one next month means that we're going to have expiring licenses. So you nice folks turning up tonight may as well make use of them. So I will send those across. Chris, I'll send yours as a DM in a second in this chat because I know you're not on Twitter, so I can't reach you on there. So I'll do that. The other 2, I'm well aware I can contact you on Twitter or LinkedIn, so I shall do that. And once again, thank you so much for our speakers tonight, Jorge, Adrian, and Brian and Chris, and there's had a whole heap of people coming along. So really appreciate taking the time to show us how cool Meadow is. And yeah, we'll all be diving into that. I mentioned in the chat that on IoT Live, Cliff and I are going to have a play with the Meadow, and I was very kindly sent a hack kit here that I'm going to demo live on IoT Live soon as well. So keep your eyes peeled for that.
So, I might get handy working.
Woo.
It's been on the to-do list for so long, and it's kind of need to get it done.
Yeah.
So yeah,
that would be good.
Get it done.
Yeah, love it. Cool. Yeah. So I mean, I'm going to stop the YouTube.